Our topic this week is bonding. So this is how we spell the word bonding, and it refers to the fact that when atoms are usually stuck together to form compounds, and compounds tend to have simple formulas, like you've all heard that water is H2O, and the H2O means there are 2 hydrogens and 1 oxygen. So we're going to have a look and see whether we can come up with the rules about bonding, so we can work out therefore what the formulas are for anything, so that I know that water is H2O, but I equally well know that salt is NaCl, and I know that, for instance, carbon dioxide is CO2, and I know that things like potassium oxide is K2O, and magnesium chloride is MgCl2. So how do I know it's MgCl2 and not Mg2Cl3 or Mg2Cl? How do I actually know that it is MgCl2? Well, we're going to look at a different one. We're going to look at magnesium fluoride, and as our starting point, in fact I've changed my mind, we'll look at calcium fluoride. If you have a look at where calcium is on the periodic table, you'll notice the calcium's here. Now the compound we're going to make is calcium fluoride. So I'll just write that up there. Its formula is Kf. That means there's one potassium and 1 fluorine. So I should say potassium fluoride, not calcium fluoride. My error. So potassium fluoride. So the potassium's here and the fluorine's there. Now it turns out that when atoms bond, they bond so that they can have the same electrons as the elements in the noble gases. And the noble gases is this column down here. So they are basically bonding so that they can become, as far as the electrons are concerned, like this column here. You can see fluorine sitting here. Fluorine, if fluorine gets an extra electron, it's going to be like neon, which is its closest noble gas. If I have a look at potassium, if it loses an electron, so if it donates an electron to something else, it's going to jump backwards and go to argon, which is its closest noble gas. So what basically happens when we get elements to bond with each other is that I've got my potassium, which I'll write up here, and my potassium has got 19 protons and 20 neutrons. And on the outside are 19 electrons. So that's my potassium. So I'm talking about this one over here. My fluorine, which I'll write down over here, my fluorine has got 9 protons, 10 neutrons, and 9 electrons outside. And that's my fluorine. Now both of them want to become, as far as the electrons are concerned, like their closest noble gas. So fluorine wants to gain 1 and become neon. So let's see if that's possible. Fluorine wants to go to 10 electrons, and therefore that means that the other one needs to go down by 1 electron. So potassium therefore goes back to 18 electrons. So we'll cross off the 9 and change it to 18. And that means that the potassium has now gone back to its closest noble gas, which is argon, which is 18, and the fluorine has gone closest to its noble gas, which is the neon, which is the 10. So the formula is therefore, if I write this down, the formula is Kf, 1 potassium, 1 fluorine. And if you notice, the potassium now has got a positive charge. It's lost an electron, so there's more protons than electrons. And the fluorine has now got a negative charge. It's gained an electron. So overall, the particular atoms want to stay stuck to each other because the positive potassium is attracted now to the negative fluorine. And that's the basis of bonding. Just want to do one more example with you. I won't write anything down, but if I've got magnesium, say, which is over here, and I've got fluorine. Fluorine wants to gain 1 electron, but magnesium actually wants to lose 2. So when they form a compound, magnesium needs to be combining with 2 fluorine atoms, because each fluorine atom can accept 1 electron. So one fluorine atom accepts 1, the other fluorine atom accepts 1, so that means that the magnesium can then lose 2. So if I've got magnesium fluoride, the formula is MgF2. And the little 2 underneath the fluorine indicates that there are 2 fluorine atoms involved and each one gains 1. That's the principle, really, of bonding in a nutshell.